I'm Jeremy Bramah, Managing Director of BRAMAHs, who are lock manufacturers which started in 1784. The company is a small company, it's got about 25 people, and we manufacture the BRAMAH range of locks, as well as a number of other products that go with it. Principally a UK manufacturer, though we do export to a variety of European countries and occasional America, North and South American countries. BRAMAHs began in 1784, and probably before that as a total entity, because Joseph Bramah was one of the great inventors of the Industrial Revolution, being the man that took 18 patents out, I think in all, including the water closet, which preceded Thomas Crapper, hydraulic press, and the BRAMAH lock was just one of the patents he took out in his time. The BRAMAH lock came from his desire to solve a problem in London, in that the latest locks, which was a Baron lock, and locks before that were all watered locks, which meant that anybody going up to a lock with a piece of metal and could make an impression of the lock, cut it out and open it. And what Joseph Bramah did was reinvent the concepts and the geometry of locking. Essentially what he did was turn everything on its side, create a shear line for which all the sliders had to be in a line, which required the correct key to line the sliders up, and once that was done, you could open the lock. Part of the problem of that time was manufacturing. Production engineering was not very sophisticated. It was early days of iron and steel in terms of the modern day understanding of it, and so there were two parts to him really. One, the concept, and two, the actual making of it. So the best thing to describe really as we start this is the concept as such of the BRAMAH lock, which he got together. And I reach over here to show you basically it's an early piece, stage antique, this, which basically shows a BRAMAH barrel, which is which harnesses the mechanism, and inside it there are a number of sliders. This one's got about 13 sliders in it as such, which are small items here, as we go around. Obviously there's a key, and you'll see in the key, which is it's a demonstration key. Basically there's lots of notches, all at different heights. Now the key, or the essential point on BRAMAH keys, is the bottom of the cut that makes the thing work. Under here on the key shank we have a nib set back at a particular geometry. And what Joseph Bramah did on the basic concept was he, taking his basic barrel mechanism and sliders and key, defined that he could make any number of key combinations. And he, as I understand it, what he meant was the diameter of this key could be bigger or smaller, in thousands of an inch, and by doing that you didn't quite know what you were coming up against as an unknown attacker. By also changing the depth of the cut and the position of the nib, he got an infinitesimal number of variations, because he was playing with all the geometry on this. Obviously for the key and lock mechanism to work, these had to match the key, also receive it. But the basic concept of Joseph Bramah was the making larger, making smaller, and different cutting and positioning of the slots, and that still applies today. This concept is probably best demonstrated, as I'll put this down for the moment and I'll pick it up again in a sec, by the challenge padlock, which is a commemorative one to show his patent. and I have to look at it to read it, but it reads, this lock requires 479,001,600 keys to open it under all its variations. So what he's basically done is define, with his patent, using this key, which looks very similar to the last one I showed you, the entirety of his concept. So that really was the concept. What then had to take place, and I can, for demonstration purposes, I think I'll just show you the mechanism work as such. If this is the barrel, which is a large size version of what's in the challenge, patented commemorative piece, if this is the barrel, and we've got the keys here, if you look at the back of the mechanism, you'll see, because all these sliders are the same length, them all come out at different positions. So there's a sort of stepped slider mechanism come out. Now this really reflects the key, and only when everything's in position can the shear line be broken, and the bolt would, this item here, which is rotating, will throw a bolt, throw a cylinder. I mean, this is just one example of what is shifting. We could put a pin on the back. So this mechanism really demonstrates the concept. Dating from 1784, 1787 is where we really start. Now, to commemorate this, and once they made it, the BRAMAH business promoted itself by putting a challenge padlock in the shop front. Now the padlock effectively read, to whom the person who could produce an instrument that would pick open this lock, they would give a prize of 100 guineas. Now this was in 1790, approximately, the challenge padlock was put in the shop front. And it wasn't until Alfred Hobbs, I believe, came over in the Great Exhibition at Crystal Palace of 1851, when he issued a challenge to Chubb, because Chubb had got a new product out, and it was a new detector lock, and he picked that in 25 minutes, so we're told, and then he came to BRAMAH's and issued the challenge to them, and proceeded to win the prize, having taken I think 52 hours spread over 16 days was the success, which, despite the prize being won, seemed to prove that it was a pretty secure lock in any day, because it was difficult to produce an instrument to copy it. There's a story in itself on the story of whether he was fair in the competition, which is a piece of archive history as much as anything, because the London Times newspaper carried a whole series of articles on whether it was a fairly adjudicated prize. It's well known in those days for people to issue challenges on locks. It had happened in America, and they came over here and took the challenge up, and there were people policing the challenges. But BRAMAH's argument at the time was that it was unfairly carried out because the instrument, the lock, was never tried during the course of his test. So it could have been wedged, and a number of other techniques used to hold it and build up a picture, when the challenge was actually to produce one instrument that would open it. Or it could, and if it had tried that, they probably would have broken any use. So you had to have it on a sort of bench type circumstances for a period of time. But the other part of the challenge was to produce one instrument, and it didn't really produce that. It produced a number to prove it worked, and it was paid out, the prize, as I understand it, with a number of grudgingly, I think it was paid, but it was paid. And in the Alfred Hobbs work that followed him, there is a claim that he used a pinprick in one of the locks, which he resold it over, which is apparently written by Hobbs. We're not sure. What we do know is that only recently, and we're talking now in September 2001, only recently we had a look at the challenge padlock, which is on display in the Science Museum, gifted by this business to the Science Museum. And what we established there, that probably isn't the original padlock, because there were features of the original padlock which were the original 1787 features. That is, the one that Hobbs attacked was 60 years. He opened it 60 years after it was first put in the shop front, and that lock did not have any false notches on it. So every Bramah barrel slider has a notch in it. That is the shear line notch. Subsequent, in about 1810, I think, the challenge, all normal locks had false notches put in to deliberately lead people down the wrong path. And what had happened on the challenge padlock is it had never been upgraded. It was just left in the shop front. So he picked a lock without the second dummy slot in it. The challenge padlock in the Science Museum is also clearly more modern because it's got more detection devices, springing devices when you come into it, and the slidering looks like it's modern steel rather than, it wouldn't have been steel in about 1780, or not that you could wedge down. But that being said, that was the challenge that came, and that Alfred Hobbs picked and walked away with 100 guineas. How can I help you? Okay. Right. So the 1851 challenge was sort of a turning point in probably lock technology. The New World had come over and opened a so-called impregnable lock. It's a material that it was 50 years old at the time. I think the point here is that technologies had to move on. There wasn't a lock around now that couldn't be opened with sufficient time, and Industrial Revolution was producing ideas, people, technology was moving on, machining was moving on, but the hunt still took a long while, because in the UK certainly lever locks were still the main form. It wasn't until the Hobbs contribution, I think, to Yale, where he contributed to the pinning systems, did the new wave of technology start to happen, because everything now in modern day has happened with pins in certain places, and they've just changed the geometry of the pins. But Hobbs was a turning point in ideas, and it was a catalyst, but wasn't an easy change, because lock technology moves pretty slowly in terms of moving on. Mark, you've asked the question, why is Europe stuck with lever locks as opposed to pin tumbler locks? And being a European and English, it's not always the best person to judge. But I think some of the issues seem to be old technology. It's very hard to change when it's a very localized industry. Lock industry, there's hundreds of lock companies around the world which have got their own technology, which have put the locks in, and they work. And once they work and they maintain it, the inbred service base holds it in situ. Only slowly ASSA in the UK in recent years, ASSA and a number of other pin mechanisms had a role to play. And even when Yale came out with the rim cylinders, frankly they're the biggest brand in the world, but they certainly haven't made inroads to the security end of the game, where lever locks, the Chubb lever locks, since the 1840s have sort of dominated in terms of the mass market. And I guess that my instinct is it's price, and price was an issue for the hardware on the door. A lot of London hardware, a lot of European hardware is on doors that haven't been rebuilt for years. The UK certainly puts on different cylinders when they're putting new doors on, or new markets, but old doors, old properties, refurbished doors, they keep the old lever locks because they're there. They've been there 200 years. Bramah's still got, half of London was built, half, but a considerable part of London was built with original Bramah locks on. Those are still on the doors. Those are still used today. Locks last for so long. Certainly lever locks do. The pin tumbler locks last just as long, depending on their use, but the pins do wear out. So I mean, my guts are telling me it's to do with price, and it's to do with the nature of the industry. The industry is serving a building product industry. A building product industry, you don't change doors, don't change locks very often. Locksmiths keep them going so long, they take the bits out, they put new bits in. All of this prolongs the lever mechanism. And whatever happens, in Europe certainly, a pin tumbler set is about 3 times the price of a lever lock. And a lever lock at that price has a price break that pins with their complete locking sets, where they're modular and functional, just don't do. Price is important. So I think it's not a concise summary, but you've got to look at the inherent nature of the industry to actually understand what where the thinking's gone and where it will go. Pin tumbler mechanisms have, on the high end, a European way, are winning, but and since the big manufacturers dominate, they will win further. But the opportunity is still for a mass producer on levers, because he can produce them so much cheaper. Okay. The Bramah mechanism I've talked about earlier, but the uniqueness of the Bramah mechanism is once you've got the mechanism, you can harness it in a number of different ways. You can harness it big size, you can harness it small size. And what I've got here is the old Newham Prison gate lock. Now, Newham Prison in London has been taken down, but this is on the prison door in the early days. You've got practically a reproduced mechanism with a key which has 1, 2, 3, 4, 5, 6 notches, and looks like it's got, well, probably 8, 9 different potential depths there. When you look at it against this key, you can see the differences. When you attack it, the nib is different size, the number of cuts is different, the size of the guide peg is different. But when you start to attack it, you don't really know how many differs you're going to face. And what they've done with this key, a mechanism, is harnessed it into a mortise. It's a rim, it's a deadlocking rim sash lock, I think is the simplest way to describe it. This is deadlocked at this point. There's no key on the other side, so you can only open it from the inside. You turn the key once to form it into a sash lock or a rim night latch. You can see the big spring working, and you turn it again to take it back. Now, this would have been built in the 1830s, I guess. And at 1830s, to have a dual action rim lock of this substance, all made of cast iron, brass, steel bolt, and this worked for years, just reflects the substance and the flexibility of the Bramah mechanism. And it particularly reflects the flexibility of the mechanism when you compare it with a small lock. And I just produced something more modern here, which is a sliding glass display lock. and if I just take the key off, we'll see that this is the same conceptual mechanism of just comparing the two keys. This small key is working, turn this piece on a glass sliding door. You can see the mechanism comes out, but the comparison I show you is really the depth and breadth of the BRAMAH concept, and also Joseph Bramah's original concept. Again, it was the moving of the diameter of the key, big or small, to different geometry levels. The nib size is different, the number of cuts is different. All of it is mixing and matching the BRAMAH lock. So if you come to a BRAMAH lock new and you don't know what you're looking at, you're working with an unknown geometry. Mark, so you really asked the question how the original BRAMAH lock had 13 different potential sliders or cuts, equivalent to something like 7 pins or 5 levers, 3 levers or something like that. And you make the mistake that most people make, which are making locks today, and indeed I've made it myself. When you read the actual BRAMAH paperwork and the concepts of the day and the claims, the original concept of Joseph Bramah was infinitesimal because of the variations in the diameter of the cuts, position of the nib. So all the models in front of you do are really just harness one line, because in engineering you have to define your geometry and then define it. But Joseph Bramah's actual concept and what he sold to people was the variations he got were infinitesimal, because you can deal with thous of an inch and you can muck everybody up in making anything. The concept doesn't change, but it does give you lots of different variations. So there was no one line to say that's what he started with, 13 or 7 or things like that. One's wrong to make that, because Bramah over the years has made it with 4, has made it with 7, has made it with 13, has made it with 9. Every single variation has been made with over a period of time, and many more can be done, or you can go back, because you're playing with this. If I said 3-dimensional, I may not be right, but you're playing with this diameter, nib positioning, cut positioning. So there's a three-way concept you're permanently changing on the BRAMAH mechanism. That still does the basic mechanism, but it gives us, going forward, any number of combinations we can still play with.
But let's talk about the BRAMAH. Let's talk about one slider, the simplest lock.
Well, the simplest lock. The simplest lock. You're defining your geometry. The cut, the depth of the cut, has to be matched by the slider. Now, if we're making a modern BRAMAH mechanism, which defines it today, the current system has 8 different heights spread over 7 different cuts, and one of those cuts is got 2 options, so it's 6 to the power of 8 times 2. Because no one person ever gets the key repeated. Most manufacturers repeat key numbers, or on the high security go new. What we do is literally tune the geometry. So our slider, by definition, could have 8 cuts today, but we can move it down to 7, or we can move the geometry within 8.
Okay, but if we have a lock, let's just take the most simple lock with one slider. That slider goes in and out.
Yep.
Is there one primary gate and then false gates?
Oh, sorry. There is always one gate in a slider and a false gate.
Right.
How many different primary gates? Because clearly there's a datum line for which there is multiple of gates. Like pins, there are multiple of different pins to split it up. But on a standalone differ system, we would have 8 gates. 8 gates. Today's system has got 8 gates.
8 depth code gates.
8 depths.
Yes.
But over the years, it would have had 8, but it's a different geometry level. So the gates have changed.
Yes. But the question is, so let's just take a conventionally keyed lock, not master key.
Yeah.
So you have one primary gate.
Yeah.
You have any number of false gates, obviously.
Yeah.
But you have one primary gate, and when that slider moves in and out, and that gate is lined up, then a ring or a sidebar or some mechanism, a fence, drop into that gate. So what functionally is the difference between the BRAMAH mechanism and the modern axial pin tumbler lock that also works on the same principle? Be it a shear line or a sidebar where there's slots where the sidebar actually drops in all the way or on 2 sides, like the Chicago 2-bar that you may be familiar with, where there's 2 rows of 4 tumblers with a slot, the gate that lines up. Functionally, what's the difference between what BRAMAH did and where we're at today, or where we're at today is a copy of where BRAMAH was at 200 years ago?
Well, we're still on film.
Yes.
Yeah. Okay. We wouldn't be so arrogant to say everything's a copy of BRAMAH where BRAMAH is today, or where we are today is a copy of BRAMAH. I think the point technically is, I don't know the Chicago product, but BRAMAH moves its mechanism, its sliders are moved to the gate, to the shear line, and the shear line we call a half washer, which can be seen. If the lighting is good enough, there's a black line here, just picking up where screws are.
Turn that in.
Okay, and this black line would be regarded as a half washer. That is a single unit in this case. Currently they're 2, for assembly purposes they are cut in half, so there's 2 half washers. But effectively we're moving our brake line, our shear line, the key moves it to the half washer.
Right, which is exactly what 2-bar is doing. They have 2 rows of 4 pins parallel to each other, and then there's 2 half-moon sidebars that drop into square gates. And,
right.
And they're compressed, and then it allows the plug to turn. So functionally, it would appear that all of the modern axial pin tumbler locks really are a design spin-off from BRAMAH. Just like all of our sidebar locks are a design spin-off of the Briggs & Stratton automotive lock that came out in 1935, which essentially is an offshoot of the combination locks with rotating gates, rotating discs with gates. There's no difference, which is exactly what Abloy did. And so there's not much new in the world of locks. And so the question is, are all of the, or most of the axial pin tumbler locks really a spin-off of a 200-year-old design?
The concept, or my own judgment is, and I'm not a world expert, I've seen a lot, but my own concept would be is that the difference has often been in the production engineering, and I suspect even the patents that have come out in recent years are all in the production engineering. That is, the patent has come from the method of production rather than the base concept that Joseph BRAMAH introduced. It's just the way it's put together is different. It's better qualified people than me would actually make the comparison. But you don't see anything new. They're just moving it a different way from a locking point of view.
So why was this lock? I can understand why it would be difficult to make a key for because of the infinite variations. But why was this lock so difficult to pick? Given if you could in fact tension your rotating shear line, so to speak.
Okay. The difficulty to pick it is that you have 13 sliders of different heights. or to actually to turn it, to pick it, to open the product, you therefore have to depress 13 individually sprung sliders, which have a number of wraps. I'd say there was 10 to, when I saw them, they had 10 to 11 coils on the springing, so that's quite heavy springing on the sliders. So you had to depress each one, and therefore you had to get each individual one to the right height, and in turn therefore you had to get a tension bar on it to actually turn the mechanism to break it. With the false notches, well, there weren't false notches on the challenge padlock, but on the one we've seen in the Science Museum, which is either reverse engineering of the original product to upgrade it, there are false notches on it. Plus, you risk damaging the sliders in terms of the product we've seen in the Science Museum, because on the way in there's individual protective covers or springing covers on the guide in this area. So it's clearly a exhibition, a challenge type of product rather than everyday manufactured product. But the real challenge was to be able to have enough hands in a small hole, because this hole is very small, so you've got no room to work in. To get 13 individually tools down a hole and then put the tension bar on and turn it was difficult in concept at that time.
So in the design of the original Brahma lock, was if you applied torque, could you bind all the sliders or freeze the sliders wherever they set from movement?
If you bind torque, you will hold the setting. Well, my understanding is if you bind the torque, you will hold the mechanism, because you're basically embedding the slider in the half washer. That is what we see today when people do it, even when they shouldn't be doing it on a bad key. But if you actually bind it with a view for manipulating to open it, what you'll end up doing is binding them all up, not one out. So to hold one in a position is your problem.
But that is the technique for picking most locks today, is to tension all of the tumblers and then back off the tension until you can slide or move each tumbler or lever until it finds its gate position.
Yeah.
Assuming you can get around false gates. So the question is, did Brahma know how Alfred Hobbs actually produced the key for the lock? Did he ever disclose that, or did they figure it out?
It's an interesting question, but the answer is probably not what you're anticipating, because